Okay. Then after that, we went into chapter 7 and 8. That was confidence intervals and hypothesis tests. And mostly you can tell between them because of some keywords, interval, error, test. Okay. And also in the testing situation, they give you more numbers. It's like there's 2 people involved. Okay. But if someone gives me this problem, well, first of all, there's no sigma at all. I know this must have been one prop because there's nothing I could use for sigma or an SX. And I know it's interval because they said so. And I got my numbers, I got my X, I got my N, and I don't have any kind of sea level. Because in real life, no one ever gives you a sea level. So unless someone comes along and forces some kind of sea level on you, you go with 0.95. So I put 35, 19, and 0.95 into one prob Z interval, and I get this. But mostly you don't publish it like that because people don't understand intervals when they're written in interval notation. So you go ahead and do that big minus little thing, and then you just say, oh, and the margin error was plus or minus 0.165. Okay. All right. And then we had hypothesis tests. It has to be some other person who makes some kind of guess. They usually don't know what they're talking about. And they said, oh, well, this is greater than or equal to 3. And you have to go out and get a bunch of data. In the real world, no one gives you data that's already been turned into means and standard deviations. So the first thing you do is you go out, you get your data, you get your own mean and your own standard deviation. You're going to need that. Okay? So you go ahead and do that. You actually do the study. All right, and then you write down what their guess was and its opposite. Then you decide where I need to be. This is definitely a test. Okay, it's got a standard deviation, so it's either Z or T, but 1, 2, 3, 4, 5, 6, 7, 8. There's only 8. I'm going with this being a T test. And then you put that in. So you go into t-test, you put in their numbers, 3, you put in your numbers. Okay, and you get the p is 0.458. Again, it's not like anybody ever gives you a significance. They expect you to be able to work on your own. So you compare it to 0.05. There's like a 45% chance that whoever said this greater than or equal to 3 knows what they're talking about. I mean, I got like 2.9. This is greater than 3. But there's a chance they know what they're talking about. So this would be fail to reject. Then after that, we did correlation, linear regression. Correlation is getting the R. Linear regression is getting that A plus BX, the equation of the line. Most of the time, you don't bother to get the equation of the line. I mean, Excel will give it to you if you want it. You mostly don't get it because people don't understand it. In fact, people probably don't even understand R. Sometimes you publish that anyway. Unless you're in research and you're really trying to present stuff, then you just present everything you can think of. But, you know, in real life, you probably just say, oh, see, these 2 data sets, they're correlated. Isn't that nice? And people are like, oh. So, but anyway, if you want to get R, we put this in list 1, this into list 2, and then stat test, linreg t-test. Okay, and you get an R. And the negative shouldn't bother you. All right, it has nothing to do with comparing it. The good zone here is cut off on both sides by positive 0.811 and negative 0.811, and so this is into the good zone on that side. So this is correlated. So you probably should, a big thing about that, how these 2 data sets are related to each other with this negative correlation. It means it's just going downhill. The more you got of this, the less you got of that. Then contingency tables. Okay, I've just skipped over that goodness of fit thing. Almost no one ever does any goodness of fit. You probably never have an occasion to do goodness of fit. But you might have an occasion to do a contingency table. They're super impressive. Okay, if you want to test something against nothing, all right, try doing nothing versus try doing this something to see what happens. Anytime you got that, you're going to get a result. So, All right, I've tried instructing DVR versus not instructing DVR, and it turns out a whole bunch of the people who got DVR instruction start actually using the DVR, and the ones who don't get any instruction pretty much don't start using it. Okay, so I want to test if that's maybe the instruction is working. So you have to put all those into a matrix. You have to make it like a 2x2 matrix. Then you put in all 4 of your numbers. And then you went stat, tests, chi-squared test. And it gave you the number 22.124. All right, now every time anyone ever does a contingency table anywhere, they've lost their chi-square chart by now. They don't even know where it is anymore because every single time they use 3.841. Every single contingency table uses that. So I look at my number compared to 3.841 and go, wow, something big and important is happening here. Yes, turns out old people can use a DVR if you teach them how. So this would be, it works. So hopefully that's just a quick summary of what we did, and it kind of puts this semester in some sort of perspective.